Hi guys, Mr. Johnny here. I want to show you a little circuit that I just made. All it does is it turns on the load and turns off the load by means of a momentary button. Ignore it turning on itself. It's not turning on itself. It's because I touched this portion. See? If you don't touch the solder side, the circuit is perfectly stable, trust me. And I took a Token Electronics version as a reference, and I modified it to work with transistors I use, 2390406. I added a again you can see misbehavior. I added this IRF 1310 MOSFET to switch the load. As you can see, the board is very small, all through hole except this bodged gate discharge resistor, which you should include in the design. It's a nice practice, very good practice in fact. And what I did to the design, I modified it to work with my transistors, plus I added an under voltage lockout, which I'm gonna demonstrate right now. Another feature of this circuit is many circuits that I've seen on the web and I tried to build myself, they have a default state they have an on state as a default state. That means if you apply power to them, the load will be on. This one, the load will be off until you touch the board in weird place or press a switch. Just like that. Hope you can hear it. And I'm gonna press and hold the switch and you'll see that the thing is perfectly stable and behaves very well. Same applies for the off state. Very nice stuff. And let me quickly demonstrate you under voltage lockout. Okay, I'm gonna turn on the load. I'm gonna decrease the voltage on my power supply and you'll see that eventually the light bulb will just dim away. See, 11.6 volts. This meter displays 100 millivolts less than the release and 0 amps consumption, and the load is off, of course. And if you try to press a switch to turn it on, it just won't. All you need to do is to recharge your battery, if it does have such. Let's say the battery is at 12.4 volts. Then press a magic switch. Ta-da! It works. So, the schematic. Again, I took a Token Electronics as a reference. They have many nice simple circuits, and all I did is I whacked it and made it more complex than it has to be. Anyway, what I did is I changed the value of this and this resistors. I added this zener, if you will, base emitter junction of this 2SC945 transistor used as a zener, as well as two forward voltage drops of these two silicon diodes, which are nothing else than 1N4148s. And that's about it. As a switch, I took the signal off of here, of the collectors and PNP. On their website, Token Electronics website, they took the signal off of this collector. And it's inverted signal. It means if the thing is on, switch is on, this is gonna be low. Now, to drive an N-channel low side MOSFET switch, I need a logical 1 high level in order to turn it on when the switch is on. So I took the signal here and it works perfectly fine. Charges the gate really fast, thus produces a nice clean turn on without any transients. I can't tell it with my scope, because I have a scope which is, yeah, but at least it doesn't blink and do weird stuff. I'm gonna connect it to my amplifier in that acoustic box, which you can see is a fake wood grain. Yeah. And the MOSFET I use this in IRF 1310. It doesn't have to be, you can use IRF Z44, IRF 3205, whatever. Again, it's good practice to add the gate to source and discharge resistor, because normally if this transistor is off, it's gonna be the gate is gonna be discharged through this 470K and 100K, and that's a bizarrely large value. Or even through like this 470K, 1K base emitter, but still a lot of resistance. I installed 22K, oh excuse me, 10K gate to source, and it works fine. Another thing though, here has to be a capacitor actually to decouple it a bit. I used 1 microfarad, and without this resistor, whenever I apply supply voltage, ignore this resistor, put a short here, I apply 12 volts, the thing will be on. Default state was on because of the sudden spike in the voltage on the supply line. If after I added this 470 ohm resistor with this capacitor, it essentially smoothed the transition up, and now the default state is off because the voltage at this node rises something like this rather than like BAM. Alright, and it consumes about 1 microamp and off. So that's that, a quick video from me. Hope you enjoyed it. Thanks for watching. See ya.